Okay, so in this problem we're asked to find all the zeros of this fourth degree polynomial function. So we would expect 4 zeros. Some might be repeated. Okay. If we did not have this hint, we'd have some difficulty trying to find the first zero. Maybe we look at a graph to find it. Okay, but we are told 1 minus I is a 0. Well, again, keep in mind then we could factor out x minus 1 minus I and be left with a third degree polynomial. Okay, so if you're given that 1 minus I is a 0, remember that's the same thing as saying that, let me write it up here. So 1 minus I is a 0, which is the hint we're given, means the same thing as x minus that number is a factor. So we should be able to divide out that factor, and we should have a remainder 0. So we just use synthetic, which is fine to do even if our 0 is this complex number. So we have our 1 minus I, and then we write our coefficients 1. Now, you will need a little bit more room, so you might want to spread this out just a bit more. -7, 18, -22, and 12. Okay, so we bring down, we multiply. So that's 1 minus I. Now again, we combine these, so -7 and a +1 is a -6 minus I. Okay. Now again, we're going to have to be a little bit careful because we have the 1 minus I times -6 minus I. So this is something you might want to do off on the side here because it's really more FOIL. So again, the next step in synthetic is to take the 1 minus I times the -6 minus I. So if we FOIL that out first, outer is a minus I, inner is a +6I, and last is a plus I squared. So we have -6, the inner terms combined to be 5I. Remember, I squared is -1. So finally we're left with -7 plus 5I. Okay, so it takes a little bit more work, but you can multiply this times this. You will get -7 plus 5I. Add, and again we add the ones without, the terms without the I, so that's 11 plus 5I. Okay, same thing again. Okay, I'll leave that to you, but if you FOIL 1 minus I and 11 plus 5I, you get 16 minus 6I. Okay, add, we get -6 minus 6I. One more FOIL, 1 minus I times -6 minus 6I turns out to be -12. Okay, and 0. And again, we would expect that since that was the hint that we did have a 0, so our remainder should be 0. Okay. Now this is sort of a big mess that we're left with. Remember, it would be started with a degree 4, so these would be the coefficients of your degree 3 polynomial. I wouldn't even write it. Remember, we have that theorem that says if 1 minus I is a root, so is 1 plus I. So instead of writing anything, just go right ahead to your next synthetic. So we have these as the coefficients for our next synthetic division. And again, by our theorem, this should be remainder 0. And we'll go ahead and check. So bring down, multiply. So that's 1 plus I. This is nice. We add, we just get -5. So a little bit easier multiplication. This is just a distribution. So it's -5 minus 5I. And we add, the i's drop out. Multiply one more time, you get 6 plus 6I, which in fact leaves you with 0. Okay. So far we've taken out 2 zeros, 2 messier zeros, but we have x minus our first 0, 1 minus I. We have x minus our second 0, 1 plus I. And now we're down to a degree 2 polynomial, and we have the coefficients, 1x squared minus 5x plus 6. And fortunately, that last one does factor, and so we can easily get it factored and get our last 2 zeros. So this is our p of x in factored form. And again, the question was to find the zeros. So we have 1 minus I, 1 plus I, +3, +2. So those would be the 4 zeros for your polynomial. Okay. Just as an aside, this is a messy way to leave your polynomial in factored form. Most of the time, these two factors would be FOILed and thought of as a quadratic factor. So just keep in mind another way to write this. Okay, if you FOIL those first two out, you get, again, I'm going to skip a few steps here, but x times x is x squared. The outer is an x times the negative 1 plus I parentheses. The inner again is a negative x times the 1 minus I parentheses. And then the last negative times negative is positive. And again, we have 1 minus I, 1 plus I. Still have x minus 3, x minus 2. Okay. And so if you clean all of this up, it turns out to just be x squared minus 2x plus 2. And then you have x minus 3, x minus 2. Okay. Which again, if we're going to write our original polynomial in factored form, we would usually leave it in this form rather than the form with the i's in there.